Hi everyone. This part is about operational amplifier. This is one of the most important amplifier. So as we know, as a, we have the amplifier circuit made by the transistor, and in this part, the other operational amplifier we call the OA or op amp. Okay, this is very popular and usually used to perform the mathematical operation. Okay, or in some case we need to have some calculation. For example, the addition, the subtraction, integration, and differentiation. And this is a kind of integrated circuit IC. Okay, if you remember the IC, the integrated circuit, and the operational amplifier is one of the kind of integrated circuit. In reality, this is the symbol of the OA. We see that the OA in principle has two inputs and one output, and the two inputs is named inverting inputs or non-inverting input. So inverting input is with the negative one. On the non-inverting input is with the positive one. And for the figure C, we can see some model of the OA, and this is kind of IC. Okay, we have for example, for the first IC, we name the 741. We have 8 leg or 8 terminals on this IC. Okay, for the ideal operational amplifier circuit, we have two main equations need to be remembered. The first one is V equal Vn and Vp. Vn meaning when the input is negative at the point N, and when the input at the positive at the P, okay, we call Vp. We always have Vn equal Vp, and the second one is In equal Ip, the current which go in the circuit at N and P, and equal 0. Okay, this is the second equation. The first one and the second one. With two main equations like this, we can calculate the with a lot of kind of operational amplifier circuits. And why we have this? Because the first one, the gain of the OA is very high. In some case, we can call it the gain of the OA is infinity. And the second one, the impedance, the input impedance of the OA is very high, or infinity input impedance. Okay, and the zero output impedance. The input impedance is very high, and the output impedance is very small. That is the two main characteristics of the OA. With the OA, we have two kind of amplifiers. The first one is the non-inverting circuit. Okay, this one, and the second one, the inverting circuit. With this circuit, we can easily have this formula, and with this circuit, we have easily this formula. Okay, we can calculate. I just show you on the course when we learned online, and we recall that with the non-inverting circuits, for example, this one, non-inverting circuits, the output and the input is not change in phase. And for inverting circuits, the output and the input is invert in phase. Okay, you can see that's on the formula. And how to distinguish two kind of this amplifier. For the inverting circuits, we have the input signal at the negative point. Okay, and for the non-inverting circuit, we have input signal which go to the positive point of the circuit. Okay, and this is two main versions. Now, if we skip this is some principle of the negative feedback. Feedback is when we mean when we have some signal at the output, we return to output to the input. We have that's called feedback. Okay, this is the illustration of negative feedback. You can see it on the slide. I will skip it. Skip it also. Non-inverting circuits, inverting circuits. The impedance of inverting amplifier. You can see it more on the slide. Okay, now next one is some basic operation amplifier circuits. And the first one is comparator. Comparator, what is comparator? Comparator is a specialized op-amp circuit that compare to input voltage and produce an output that is always at either one or two states. Okay, indicating the greater or less than relationship between the inputs. For example, the input we have the first one is a signal, and the second one at the negative we connect to ground. So the output we have a rectangular form, meaning we have 1, 0. Okay, two state. That is comparator. So what does it mean when at the input we have two different kind of signal? The output will have the value 1 or 0. One or 0. The comparator. We can also change the ground by the other values of voltage, and we have another comparator circuit. Okay, I will concentrate about some principle circuits which use OA. The first one is the summing. Okay, we have summing. In the summing circuits, V out will be a formula of the summing of the V in. Okay, and how to realize this? We have V in 1, for example, V in 2. Both of this signal will go to the negative point, and as the output we have a V out, is summing of the V in. Okay, and you can easily prove this formula. And we also pay attention that we have the negative signal, negative sign here. It is not so important. When we change, we would like to change this to the positive. We can change the pole of the output. So this is very easy to change. The main issue here is the V out is summing of the V in. Okay, and this is how we connect it into circuits. We have summing circuit. When we have more input, for example, we want to have the summing of the V1, V2, V3, etc., Vn. We can use this kind of circuit. Okay, all of the inputs will go to one inputs of the OA. For example, in this case, all of the inputs will go to the negative point and will feedback by RF. Yeah. Okay, the current here is the direction of the current which in the book of Floyd, so a little bit different with our direction, but it's not important. In always we have always this formula by Kirchhoff's law. Okay, for example, I go through the RF always equal the summing of the I1, I3, I2, and in this case the V out, this is formula V out, and you can generalize this with the case of n inputs. For example, V1, V2, V3, Vn. The summing of output is V1, V2 plus plus Vn. Okay. The next one is subtractor. The subtractor is different from the summing circuits. And how we realize this? The first signal will go to the end point, and the second signal will go to the positive point. By this kind of connection in the circuit, we can easily prove this formula. The V out is the function of the difference of V1 and V2. Okay, you can see in this formula, V out equal a K coefficient and of the V2 minus V1. So this is the subtractor circuit. Okay, this is small example. You can see it and try to do it yourself to understand how does it work. So adder and subtractor. This is the adder and subtractor circuits. We compose of both subtractor and summing circuit in one circuit. The next important one is integrator circuit. For this OA circuit, we use the capacitor at the feedback point. Okay, you remember that with the summing or subtractor circuit, we have at this point the resistor, but for integrator circuits we use the capacitor, and by using this capacitor we can have this formula. Okay, pay attention that the current which go through the capacitor I, the formula is equal dq over dc. Okay, the differential, and q equal c minus c multiplied by u. U is voltage of the capacitor. Okay, and by using this you can replace q in these equations, and finally you can have this equation, meaning dv out over dt equal minus v in over r in c. I just retyping this formula. Okay, this formula is retyped like this, and from this you can easily have the V out equal minus k. This is a coefficient, and integrators multiply with integration of the V in dt. Okay, so this is the original of the integrator circuit formula. You can see that if you have the input signal is the V in, the output you can have a function of the integrators of V in. Okay, this is one of application, application of the integrator circuit. You can change the rectangular form to the triangular form of a signal. Okay, the next one is differential circuit. The differentiator circuit is very simple. By changing the position of the capacitor and the resistor, okay, but of this circuit, okay, you can, this is the integrator circuit, and you change the position of the capacitor and resistor, we can have this formula, okay, meaning the V out will be a functions of the V in over dt. Okay, this is the function of the differentiator circuit. Okay, so the two main circuits of the four principal circuits of the op-amp is, the first one is the summing circuit, and second one is the subtractor, the third one is the integrator, and the last one in this part I will just talk about the differentiator circuit. That is the four main circuits of the application of operation amplifier in this section. Okay, thank you very much.